Our next speaker is Stephanie Bricker, a colleague from BGS. Steph's worked for BGS on a number of different projects, particularly looking at quaternary aquifers, and she's worked a lot in London and the Thames Basin on urban groundwater issues, as well as in Glasgow. But today she's going to talk about a pilot groundwater monitoring network for Glasgow that was done as part of CUSP. So, Steph.
So today I'll talk to you about urban groundwater and how we've been able to improve our understanding of urban groundwater systems in Glasgow as a result of a pilot monitoring network that we've developed. I just want to offer my thanks to Helen and to Brighid, who have played a significant part in this research project as well. So the story of urban groundwater monitoring in Glasgow, very different to Hamburg. And it starts off a little bit sad because we don't have systematic groundwater monitoring. And to address that, and working with Glasgow City Council, we've been trying to develop a pilot monitoring network. And the story ends on a little bit of a happy note because a longer-term monitoring strategy is starting to be developed. Before I get into the detail of Glasgow itself, if we take a step back and just think about urban groundwater in the UK, we've already learned over the last couple of days that these are highly variable environments. They're very modified by human activities, and we really want to try and understand these systems more in terms of their groundwater response. But we're hindered because there isn't very much monitoring of these shallow aquifers in our urban areas in the UK. But in the UK, we are actually very good at groundwater monitoring in terms of levels and in terms of quality, but we have to look at the drivers. So historically, the driver for groundwater monitoring is abstraction, so water for public water supply, for agriculture, for industry. And in the UK, most of our groundwater resources come from the deeper bedrock aquifers. So that's where all our monitoring is, and we have failed to kind of monitor and to understand in a lot of detail these shallow urban systems. But what we've also learned over the last 2 days is that there is a lot of data out there. There's a lot of site investigations that have collected groundwater data in terms of levels and quality. And over the last few years, we've seen an increase in the amount of urban groundwater research, particularly in terms of recharge and contamination. So there are these local pockets of data out there. But of course, we don't want pockets of information. We want a city-scale overview of urban groundwater. And why do we want that? What's the motivation? Here we've got just a few examples of the drivers. So we need to understand more about our baseline urban groundwater systems. We know that our urban water cycles are different to our regional water cycles. We're increasingly seeing the value of urban water environments from an ecosystem services point of view, so we want to understand it from that respect. Over the last few years, there's been devastating flooding in lots of our cities. What's the role of groundwater in those flooding events? What's the role of sustainable urban drainage in dealing with that surface water? And of course, we've got the contamination legacy and the requirements to meet the Water Framework Directive. These are all issues that we can only answer if we've got that understanding, and at the moment we're hindered because we don't have the monitoring. So we know why we want these monitoring networks, and we know that the site investigation data is probably our best chance at the moment of getting that. So we set ourselves 2 questions. The first one is, can we use site investigation data to understand urban groundwater at that city scale? And can we use site investigation data and the existing infrastructure, so the boreholes that have already been drilled, to help establish a pilot monitoring network? So this is where we get down into the nitty-gritty and we start to try and collect all of that groundwater data from the site investigations. And in the period from 2004 to 2011, we were able to identify more than 300 monitoring boreholes. And at this point, we're all rubbing our hands with glee and we're going, yeah, there's loads of data out there. This is going to be fine. Of course, it's never that simple. And there's lots of issues with this data. Obviously, these site investigations don't always run for years. Some of the data will just cover a few months. Some sites or boreholes will be monitored for more than a year. Some boreholes will have 15-minute groundwater level data. Other boreholes will have just got one-off groundwater level measurement. The map shows us in Glasgow where we've got some of these major redevelopment sites. So there's the Commonwealth Games site, Shorefields, the M74 extension, and the red boreholes are where Glasgow City Council themselves installed some monitoring. And you can see another issue when you're looking at this map in terms of the spatial coverage. So there's a lot of clustering with these monitoring boreholes, and most of them follow the valley of the River Clyde itself. But by far the biggest problem for us was the borehole metadata, and Helen spoke about this when she gave her presentation on ASK and GSpec. And she highlighted the fact, and just to reinforce this, that the information that we needed wasn't always readily available. And site investigations are carried out for a very specific purpose, and they're carried out to a very high standard. But we come along and we want to try and use this data for a very different purpose. So some of the information we needed wasn't there. So when we first started drawing that data together, for more than half of the boreholes, we didn't know the depth and we didn't have a datum for the groundwater levels. And it was almost, well, in nearly all cases, we didn't know which geological unit that borehole was monitoring. So with the help of Glasgow City Council and Simon Watson, we started to pull all the pieces of the puzzle together to go back to look at the PDF reports, to look at the borehole logs, to look at the Excel spreadsheets, so that we can start to get all of that data that we need. And we were vastly helped by the 3D geological model to help validate some of the decisions that we were making. So once we've got all that data together in a way that we can use it, which took quite a long time, we can then start to build up our hydrogeology conceptual model. And this is very much an iterative process, and at the heart is the site investigation groundwater data and the 3D geology model that Katie spoke about earlier. And what we were able to do was we were able to import all of that groundwater level data and the borehole construction information into the geology model. We can cross-reference that with the borehole logs, and we can start to look at how groundwater levels are varying within the different geological units, what's the seasonal variation, what's the spatial variation in groundwater levels, and we can start to draw on our geological cross-sections where we think the water table is or what the groundwater levels are. So once we've got a more robust or a better understanding of how we think these groundwater systems are behaving, we're then in a position where we can start to design a pilot monitoring network. So the map on the screen shows where we've got our site investigation monitoring boreholes, and now what we've done is we've coloured them up to show which geological unit we think they're monitoring. And what we decided quite early on in discussion with the geologists and looking at the geology models and looking at our groundwater level data, that we would focus on monitoring 3 units, the Gurrock sand, the Bridgeton sand and the Paisley clay. And I know it sounds very odd to be monitoring groundwater in a clay unit, but we heard earlier from Tim and others that actually there's a high proportion of sand and silt in there, and we are seeing the groundwater level variations as a result. We could also start to make decisions about what borehole spacing we should have for the monitoring network and how frequently we should be collecting groundwater level measurements. Fairly early on, we decided that the monitoring network would focus on groundwater levels as well as collecting temperature and conductivity. We're not doing any chemistry sampling at this stage, and that's largely due to the contamination issues that would need to be overcome to enable that. We have no choice but to focus on the River Clyde Valley because that's where the existing monitoring boreholes are, but also that's where a lot of the redevelopment is happening, and that's where we probably want to have our groundwater understanding. The other opportunity here, because we're by the estuary, is to start to look at if there's any tidal effects in our groundwater levels. So there's lots to think about and lots that we could look at. So then we come to actually installing the pilot network, and we identified 22 potential boreholes that would be spread out along the River Clyde Valley. And that was based on what unit the boreholes were completed within, what the construction of the borehole was, where it was located, whether the site was secure, what the access arrangements were like. Actually, when we came to install our data loggers, we found that only 6 of those 22 sites were suitable. And that's mainly because the site investigation boreholes are generally designed to be temporary, so lots of them are lost, destroyed, covered, or you can't get access to them. And in some cases, the borehole completions weren't suitable for a longer-term monitoring network. So we went ahead and we've installed data loggers in 6 of the boreholes. They're shown on the map as the green and yellow squares. Within 1 month, one of our sites was vandalised. This is the reality of working in big urban environments. So we have 5 monitoring boreholes in our pilot network at the moment. 3 are measuring the Paisley clay and 2 are measuring the Guruk sand. We haven't at this stage been able to identify any boreholes in the Bridgeton sand member. But we've got 2 years worth of good quality data coming out. This is plotted up in the graph along with the rainfall data and river levels for the River Clyde. So now what we can start to do is we can start to look at the differences between the geological units. We can start to look at the relationship with rainfall. We can start to look at whether there are trends as you move away from the River Clyde. We can draw out the tidal influences, and we can really start to validate the conceptual model that we developed before we put the pilot network in place. So we're in a fairly strong position at the moment. But now if we look in the longer term, this is where we get some good news. SEPA will be taking over the longer term monitoring of these boreholes, and the data will be available to Glasgow City Council and to other stakeholders. But more importantly, there's a desire to extend and expand this monitoring network. So when new site investigations are planned, Glasgow City Council and SEPA will be having that conversation and saying, is this site suitable? Are there some key boreholes that we should be adopting into our monitoring network for that longer term monitoring? And through that, there's 5 identified so far. So just to come up with a few conclusions, let's answer the questions that we set ourselves. Site investigation data is very valuable in terms of pulling it together to get a city-scale overview of the groundwater systems, but there are a lot of limitations that you need to overcome. And I think the ASK and the GSpec work will really help us in terms of getting good quality data in. But one of the things that we always need to remember is that if we're going to use these local pockets of information, that we're placing it within a wider conceptual understanding that we're quite happy with, so that we're always looking at the bigger picture when we're looking at this data. One of the other really valuable things, I think, is that having a pilot network is really good to test your conceptual model before you start spending lots of money in implementing really wide-scale monitoring networks. We certainly found it to be a useful tool. And finally, just to finish, let's think about how we transfer this into other cities. The geology of Glasgow is quite comparable to lots of other UK cities. The drivers for urban groundwater monitoring are similar in many of our cities. So we ought to be thinking about the lessons learned and whether we should be implementing similar strategies elsewhere in the UK, and not maybe just in the UK but overseas. Thanks.
Thanks, Steph. That was a really nice overview of the work we've been doing. We've got time for a couple of questions if anybody has questions for Steph.
If SEPA decided they wanted to monitor groundwater in another city, such as Edinburgh, what would you advise them to do? To drill their own bespoke monitoring borehole, or to try and go for conversion of existing site investigation monitoring boreholes?
It's a really good question, and it's something that we've considered, because the cost-benefit analysis of reusing existing boreholes. And what we found was actually going through this process of identifying existing boreholes and looking at the existing site investigation reports, you're getting more than just a borehole that you can instrument. You're getting a lot of additional information and value that helps you build up that bigger picture. So I would say if there are suitable boreholes that you're aware of that have all the requirements for a longer term monitoring network, so good access and good completions, I would use them. But it is very labour intensive doing that. So there is definitely merit, if you've got the money available, to drill bespoke boreholes where you know you've got particular problems and you don't have existing infrastructure that you can use.
Can I just add to that? Is the trick not just know where the council has provided money for infrastructure development? There's already a borehole programme being planned, saying we can capitalise on this to use one or two, enhance what the contractor's doing, and you pre-order it almost.
Yeah, well that's what's happening in Glasgow at the moment. Yeah, yeah.
That's exactly what we've talked about with both the City Council and SEPA. So we've got this dialogue going on that we can capture that.
Obviously in Glasgow you've got the 3D geological model and monitoring network to actually understand where the actual aquifers are. If you're rolling out to a new city, how important is it to have that kind of information as a background to developing a monitoring network?
Yeah, I mean it's crucial really, having that understanding, whether it's a formal 3D geological model or whether it's just having that local knowledge and the borehole coverage and data to be able to do it. In Glasgow it was really useful for us to have it because, like I say, where data and information had got lost from the site investigations and we didn't know necessarily which, or there was no record of which geological unit they thought the borehole was monitoring, what we can do is slot that borehole into the geology model and go, look at my groundwater levels, look at the completions and think, right, okay, I know what I'm monitoring here. If you don't have that, you're sort of on hiding to nothing, I think.
I think we better move on to our next speaker. Thank you very much again, Steph.